Okay, so let's have another example. So this is a continuation of finding the x in a rational inequality. Okay, so again, make the right hand side of your expression to be 0. So I'll need to transfer 4 from right hand side to the left hand side. So 3x minus 4 over x minus 1 minus 4 less than 0, or greater than 0 rather. So would like to simplify this equation, this expression. So further simplifying, so this will be 3x minus 4x will be negative x. Negative 4 minus negative 4 will be 0. So this will be negative x over x minus 1 less than 0. So again, separate the numerator and the denominator and equate both of them to 0. So the first x will be equal to 0 and the second x will be equal to positive 1. So we will be having a number line wherein the partition will be assigned to the 0 and 1. So let's have a number line. Okay? So would like to highlight this one because this will be our main expression which will be used for the argument verification. Okay, so this will be, I think I am negative 2, negative 1, 0, 1, and 2. Okay, so let's place a partition at 0 and at 1. So this will be region A, B, and C. So let's prove the argument at if the values lies on region A. So let's have x is equal to negative 1. So this will be negative and negative 1, where negative 1 minus 1 less than 0, 1 over negative 2 greater than 0. So this will be negative 1 half is greater than 0, and this is false. Okay, so for B, so let's have an example, will be x is equal to negative positive 1 half. Positive 1 half will do. So this will be negative 1 half over 1 half minus 1 is greater than 0. So this will be negative 1 half over 1 half minus 1 will be negative 1 half. So negative 1 half divided by negative 1 half will be equal to positive 1. So 1 is greater than 0, so this argument is true. So I think we will be having an interval lying on the B region. Okay, and so let's have an example at C. So let's have x is equal to 2. So this will be negative 2 over 2 minus 1 greater than 0. So this will be negative 2 over 1. So negative 2 greater than 0, and negative 2 greater than 0 is false. So our interval will lie between 0 and 1. So this includes 1 half, 1/4, or 3/4. So any of them. So any rational any real numbers lying between 0 and 1. However, we would like to verify if 0 is included to the solution and 1 is also included to the solution. So let's try to verify. So if x is equal to 0, then this will be 0 over 0 minus 1 is greater than 0. So 0 is greater than 0, apparently this will not be true because 0 is equal to 0, no? It will never be greater than 0. Okay? So this, it means that 0 will not be included. So I will be placing an open circle here. Okay? If x is equal to 1, then this will be negative 1 over 1 minus 1 greater than 0. So this will be negative 1 over 0. Again, this will give us an undefinable answer. Hence, 1 should not be a value of x. So I will be placing an open circle here. Okay? So that is for rational inequalities.